Hello everyone, welcome to a new episode of Pilotology. Today we will be discussing the forces of flight, so your instructor never challenge you again. I remember when I was 12 years old, I used to look at the sky, the big, massive, gigantic airplanes in the sky, and I used to wonder, how come these big airplanes are able to keep themselves in the air? I went to my dad and I asked him, Dad, how come this is possible? He told me, because they have big engines. I was like, your car have big engines. How come you're not driving it in the air? I went to Google, I looked it up on the internet, I found the magic word. The magic word was lift. And then I grew up and I went to flight school and I learned it's not only lift, it has more to do with it. And in today's lesson, we're gonna learn the more to do with it, the four forces of flight. Four forces we have acting on an aircraft: lift, weight, thrust, and drag. Yes, it's not only lift which is acting on the aircraft, there is three more forces we need to understand. First force, as we discussed, is lift. It's the perpendicular force to the flight path and to the lateral axis as well. It's the upward force created by your airfoil or your wings, which contributes to keeping the airplane in the air. Opposite to lift, we have weight. Weight is the force that pulls the aircraft downward because of the force of gravity, which acts vertically downward. The third one we have is thrust. Thrust is the forward force produced by power plant, propeller, or rotor. And if you think about lift as the force that keeps the airplane up in the air, then thrust is the force that keeps this airplane moving forward. Finally, on the other side, we have drag, which opposes thrust. It's the rearward retarding force, which limits the forward movement of the aircraft. So again, we have lift, which is the upward force, and its opposite, the weight, which is the downward force. We also have the thrust, which is the forward force, and its opposite, the drag, which is the rearward force. Lift need to counteract the weight of the aircraft to keep the aircraft flying in the air. If the lift force becomes more than the weight, that means my vertical speed is going to increase and I will be able to climb. And the opposite is true. If weight exceeds lift, this means the vertical speed will decrease and the aircraft will start losing altitude. And same for thrust and drag. Thrust need to counteract the drag in order to keep the airplane flying forward. If thrust increases more than drag, then the aircraft will speed up. And if drag increases more than thrust, the aircraft will slow down. And of course, if they are equal, you're going to maintain the same airspeed. We need to understand that in a straight, steady, unaccelerated flight, the sum of all those forces needs to be equal to zero. If lift is equal to the weight and thrust is equal to the drag, then the aircraft will perfectly maintain its airspeed. It's not going to accelerate or decelerate. And then the lift will cancel out the weight and thrust will cancel out the drag, giving me a net force equal to zero. That being said, that doesn't mean that the lift is equal to thrust or the weight is equal to drag. The true statement to say is the sum of all the upward force will be equal to the sum of the all downward forces. The sum of the forward forces will also be equal to the sum of the backward forces, so they can perfectly counteract each other and the net force will be zero. Now let's actually discuss how those four forces work. I'll start first with lift. I wish I had definite answer 100% on how lift work, but the truth is there is numerous theories on how lift is generated. And I really find it funny. Humans have invented aircrafts and then they're trying to figure out how they actually work. As I mentioned, there is a lot of theories around it, and if I choose to cover them, probably that's going to be a 15 minutes video by itself. So I'll choose to cover the most known ones. Before I get into the theories, unfortunately, I will have to take you back to the physics class in high school. Let's talk some physics. First, we need to understand that air is a fluid. Yes, fluids are not only liquids, air is considered a fluid as well. Just like any fluid, air has the ability to flow and has the ability to take the shape of its container. The air molecules are very light, but they still do have a certain mass. And if they have a certain mass, they will have a certain weight as well, right? And if they do have a weight, then they will have a force. I want you to think about it this way. You get out of your house in a very strong, windy day, and you get hit by strong wind, which caused you to move quickly. So what happened is those air molecules, which had a specific weight, put the force on you, which caused you to move, to accelerate. And this is a very basic example of what force means. And finally, since the air has force, then it will have pressure as well, which is defined as the perpendicular force per unit area, and we call it atmospheric pressure. Sounds a little bit complicated, but trust me, all what you need to know as a pilot is the air molecules has certain weight, that's why they have force, that's why they have atmospheric pressure. And then now, since humans understood the physics of the air, We invented airfoils. Airfoils are shaped surfaces like your airplane wing, propeller, or tail. We humans studied the physics of the air, tried to understand how they work, and then we invented airfoils, trying to manipulate those principles and laws we studied to get certain reaction from the air. A certain reaction like lift, which keep us in the air. Now let's actually discuss the theories of lift. The first one we're going to discuss is the one mentioned in P-Hack Chapter 5. And this is the one you will be telling your DPE or your check airman as well, because it's mentioned in an FAA source. This theory is based on Bernoulli's principle. Basically, there is a guy called Johann Bernoulli, came out with Bernoulli's principle, which stated that as the velocity of a moving fluid increase, its pressure decrease. An application to this principle is the Venturi effect. So let's get into some drawing here on our iPad. So scientists came up with a Venturi, which has a specific diameter in the inlet, then it gets narrower toward the middle, and then it widen up again to the same diameter toward the end. And they let some air molecules in a fluid. Because the inlet and the outlet has the exact same diameter, then the air entering the venturi has to be the same exact amount of air leaving the venturi. What they notice is the air molecules flowing, and when it gets to the narrower area, its velocity increases. Its velocity increases because they're trying to pass through the same exact amount of air at the same amount of time as the rest of the venturi. And when its velocity increases, they notice that the pressure decreases. And again, when they get out to the wider area, like they came from, what happens is the velocity decreases to the normal velocity they were at. And again, when they notice that when the velocity decreases, its pressure increased again. Which proves Bernoulli's principle. As the moving fluid velocity increase, pressure decrease, and when the velocity decreases, pressure increases. And this is the Venturi effect. The theory in the P-Hack Chapter 5 is based on Bernoulli's principle to generate lift. So we have a wing, which is shaped more flat on the lower part, and it's a little bit curved on the upper part. And we have some air molecules coming in contact with the wing. So what's going to happen is you're going to split some to the upper part and some to the lower part. The one in the upper part, they have more distance to cover because it's curved. And the one on the lower part has less distance to cover to reach the end of the wing or the airfoil. So the theory says they have to meet at the exit at the same time. What they're gonna do is the air on the upper side of the airfoil will increase its velocity in order to catch up with the other one. And then when its velocity increases, its pressure decreases, as we know from Bernoulli's principle, which the one on the lower surface doesn't have this much distance to cover. So its velocity will be lower. And when the velocity is lower, the pressure is going to be higher as well, right? So again, I have an area of high pressure below the wing and an area of low pressure above the wing. You know that high pressure moves into low pressure, so the high pressure air under the wing will try to move into the low pressure air above the wing. But literally there is the wing in the middle, there is surface. So what's gonna happen, it's gonna add pressure to the airplane, which causes the airplane to be lifted up, which will cause the lift according to this theory. So this is the theory of lift according to Bernoulli's principle, and as we agreed, this is the one you're going to be telling to your DPE, because this is the one mentioned in P-Hack Chapter 5 in a reliable resource by the FAA. However, some modern science debunked the theory of generating lift, and one of the companies is NASA, which claimed the theory of lift is wrong. And I do agree at some points which NASA mentioned when they claimed this theory as wrong, because they said, okay, then the upper part of the wing has to be curved in order to have more distance for the air to cover, right? So how come flat wings generate lift like the Wright brothers aircraft? They have the exact same distance above the wing and below the wing. So that doesn't explain how flat aircraft does generate lift. This is bring us to the other theory of lift we have today in our lesson, which is based on Newton's law of motion, specifically the third law of motion, which is for every action there is equal reaction opposite in direction. Starting pushing a wall, and I put a force, let's say 200 newtons. This is just an imaginary number, we are not physicists, right? So I put the 200 newton toward the direction of the wall. What happened is, for every action, there is an opposite equal reaction. So the wall put the 200 newtons back to me, which caused me to move away from the wall. According to NASA, it's true that the air at the upper part of the airfoil has higher speed than the air at the lower part. But this is not how we generate lift. We actually generate lift because we deflect the air downward. So let's go back to drawing again. And we have the exact same airfoil as we had before. Then it come contact with the air molecules. So according to Newton's every action opposite equal reaction, what's gonna happen is, again, just like we discussed, the air is going to split to the upper part and lower part. According to the theory, the airfoil is shaped and designed to take these air molecules and deflect them downward, both upper and lower. So when the air is deflected downward and opposite, the upper and the lower, and opposite and equal reaction from the air is gonna result in the air pushing me back, pushing the wing and the aircraft back upward. So here is the action, which is we deflected the air molecules downward, and the opposite reaction is the air pushing me upward, creating the lift that keeps the aircraft up in the air. If this makes sense. This is the other theory of lift. It's good to know it because it's also mentioned in PHAC, but in chapter 4, which have most of the lift theories there. So it's good to know if you get asked by your instructor or DPE. This is the equation of lift, and we can manipulate lift in different ways as pilot, by like angle of attack, or let's say increasing the airspeed. Think about it this way: if you increase the angle of attack of airplane, that means you're deflecting the air at sharper angle downward. So when the air get deflected more downward, what's going to happen is it's going to raise your aircraft or generate more lift to your aircraft. You can also increase the airspeed, which will have more air molecules on your wings, and when you have more air molecules, you're deflecting more air molecules downward, which means more air molecules deflecting you upward, which is lift. And also the factory or the manufacturer can manipulate the surface area of the wing itself to generate more lift, right? And we are done with the theories of lift. This was the hard part, so let's move into the other forces. The second force we have is the weight, the aircraft weight. We mentioned before that lift acts perpendicular into the flight path. However, weight acts downward toward the center of the earth. So if this is lift and the aircraft moves, lift will be perpendicular into the flight path. However, the weight force will always be aiming like downward toward the center of the earth, or gravity. So again, weight equal mass times gravity. Your aircraft has a mass and we have a gravity force creating the weight force. This is how it works. And as we mentioned, the lift has to counteract this weight force in order to keep the airplane in the air. If lift is more than weight, we will climb. If weight is more than lift, we will descend. But don't get me wrong, that doesn't mean we actually climb or descend only based on the lift force. It has more to do with it, which is the excess thrust. This is way beyond the scope of this lesson. It will take 10-15 minutes video just to talk about the excess thrust and the power and thrust curve and all this stuff. All what you need to know, yeah, if lift is more than drag, then yeah, the aircraft will climb, and if it's less, it will descend. And this is it for weight. Now let's talk about the third force, which is thrust, the force that keep us moving forward in the air. And thrust is very simple. We already mentioned Newton's law, right? Thrust is the forward force. It will be generated by your propeller, power plant. And what a propeller do is it moves and it sucks air. When it sucks air, it pushes the air backward. It starts pushing the air backward. When the air is pushed backward, the opposite reaction and equal reaction of the air is to move the aircraft forward. And this is how the thrust work. When your propeller moves faster, it pushes more air backward, so it's more air pushing you forward. That's how we're able to increase our airspeed, manipulating the throttle. And when it moves slower, that means less air pushed backward, which is less air pushing you forward. This is if you have a propeller, but let's say you are a jet aircraft, you don't have a propeller, so what they do is they push blast of hot air backward, and an opposite reaction of this hot air pushing backward, this hot air will start pushing you forward, creating thrust. So it's the same concept, different mechanism. The last one we're going to discuss is drag, the opposite force of thrust, which acts rearward parallel to the relative wind. At the beginning of the lesson, we mentioned that air is a fluid. Any fluid will have something called viscosity, which is the resistance to flow. Water is a fluid and it has low viscosity. That means water will be much easier to flow than oil. Oil, which has a higher viscosity, that means higher resistance to flow. Air viscosity is relatively low, but still it has some viscosity to a certain degree. That means the air will have some resistance to flow as well. There is also friction. We know what friction is. It's when a fluid flow over an object, there is a friction, a contact between them. Friction depends on the surface roughness. So the more rough the surface is, the higher the friction. And the same concept applied to the airplane wings or the airplane body. It may seem very smooth to you, but under microscopic level, it has certain degree of roughness as well, which causes a friction between the air molecules and the body of the aircraft. So viscosity combined with friction causes us drag because of the disturbance of smooth airflow, slowing the airflow down and slowing the aircraft down as well. With that being said, there are two types of drag: parasite drag and induced drag. Let's start with parasite drag. Parasite drag happens because of the disturbance of the smooth airflow over your wings and over your aircraft generally. We discussed how lift and thrust work, and for lift and thrust work we need a very smooth airflow doing what it's supposed to do. Anything that slows the smooth airflow or disturb it is gonna cause us drag. It's gonna cause us to slow down. Parasite drag itself has three types, which is form drag, interference drag, and skim friction. First, let's start with form drag. Again, air is a fluid. That means it doesn't resist deformation and it takes the shape of its container as well. Form drag is that smooth airflow is being interrupted because of the shape of the aircraft. So let's say your airflow is going very, very smoothly and suddenly it hit an antenna or it hit a tire. This antenna will disrupt the smooth airflow for some time, which will cause us the form drag because of the shape of the aircraft itself. Eventually, it will go back to being smooth airflow, but how quickly it goes back, that determines how much drag have been generated. Second type is the interference drag. Interference drag happens because of the mixing of airflow streams on an aircraft. Usually, you're going to find this in angles. So we know that the air on the wing flows at a different speed than the air on the fuselage. So in places like the wing root, when the air on the wing and the air on the fuselage start meeting, because they have different speeds, so they're gonna get mixed and they're gonna get interrupted for a period of time, which causes a disturbance of the smooth airflow, causing us the interference drag. Another example from our Cessna is the connection between the wing strut and the wing, or the wing strut and the fuselage. So mainly angles where you're gonna find the interference drag the most. And the last type of the parasite drag is the skim friction. As we mentioned, the airplane body and wings have a certain roughness, you can see them, but at a microscopic level they actually do, which causes the air molecules to generate friction with the body. And also stuff you can visibly see like screws and hinges, all this stuff gonna cause friction as well, slowing the smooth airflow, causing more parasite drag. Parasite drag increases as a square of the air speed. So the faster your aircraft is, the more all this type of drags we just discussed going to increase, the more you will have parasite drag. And this is it for the parasite drag. Now we can move into the second type of drag, which is induced drag. Induced drag is created because we create lift. Whenever we creating lift, we will be creating induced drag as well. We mentioned Bernoulli's principle, and we said the lower surface of the wing will have higher pressure air and the upper surface of the wing will have a lower pressure air. We also mentioned that the higher pressure below will try to reach the lower pressure above, but there is the wing surface in the middle, right? This is true, but where is it actually able to meet? The air is able to meet on the wing tip where there is no more wing surface left. So at the wing tip, the high pressure air will try to reach out to the low pressure air, creating something called wing tip vortices, which are circular patterns that disturb the smooth airflow, creating induced drag. The more lift you generate, the more induced drag you will generate as well, because you will have more wing tip vortices. Induced drag is inversely proportional to the square of the airspeed. So the slower your airspeed is, the more induced drag you will generate. And this is it for the 4 forces of flight. I hope it makes sense. It's a lot of physics, but once you actually understand it, it's pretty simple. Please make sure you like this video and subscribe to the channel. I will be posting a lot of checkride preparations for private pilots, commercial pilots. So please make sure to subscribe and have a great day, everyone.